Today we'll be talking about water. Water consists of 70% of the human body and over 80% of the Earth's surface. When hydrogen bonds in air, it combines with oxygen and produces water. So H2 plus O2 produces water, which is what? H2O. So balancing this equation will mean, okay, since there are two oxygen atoms on the left, we have to put 2 here to make the oxygen atoms on the right to be 2. But now hydrogen is 4, so we have to put 2 here to balance everything. And now the equation is balanced. Now this is the molecular structure of water. You can see the two hydrogen atoms bonding with the oxygen atom, and you can see that the bond is a covalent bond, okay, and there's a single bond each, and this angle between the bond is 105 degrees. Let's go to use of water quickly. Water is used for drinking, bleaching, washing, in steam engines, cooking, electricity, and production of other chemicals. So water is a highly useful chemical. Okay, so let's talk about water as a solvent. Water, being a polar solvent, makes it very possible for other polar substances to dissolve in it. So what do we mean by polar? The areas of the hydrogen is partially positive, while the area of the oxygen is partially negative. Okay, so water can also dissociate to form hydrogen ion, which is positive, and hydronium or oxonium ion, which is negative. So this makes water to exhibit a polar nature, which makes polar substances like sodium chloride, tetraoxophase 6 acid to dissolve in water. Because of this, water found in nature like ponds, rain, wells, streams usually have dissolved substances in them. So they usually have dissolved salts and minerals in them. For example, they usually contain dissolved calcium carbonates, which contributes to the hardness of shells of sea animals or for the strong teeth of animals drinking from this water. This brings us to the classification of water into hard and soft water due to the kind of materials dissolved in it. So hard and soft water. Water is classified as hard if it does not foam readily with soap. Hardness of water is caused by presence of calcium or magnesium tetraoxosulfate 6 or the presence of calcium hydrogen triiosocarbonate in water. So soft water is water that does not contain these mentioned compounds, as it foams readily with soap. We have temporary and permanent hardness. So temporary hardness is the kind of hardness that is caused by the presence of calcium hydrogen triiosocarbonate 4, and here is its formula. So when this material is dissolved in water, we have temporary hardness. Now, removal of temporary hardness, we can boil it. Now when we boil it, the heat breaks the calcium hydrogen triiosocarbonate 4 to produce insoluble calcium triiosocarbonate, which can be easily filtered out. So the calcium hydrogen triiosocarbonate 4 was soluble, but when we heat it, it produces the insoluble calcium carbonate, which can be easily filtered out. So the next procedure of removing temporary hardness is by adding slacked lime, which is calcium hydroxide. So the soluble calcium hydrogen triiosocarbonate reacts with calcium hydroxide and brings out the insoluble calcium carbonate, which can be selected out from the water, and the water now becomes no longer hard. Now, adding excess slacked lime can cause permanent hardness. That's why we said adding calculated amounts of slacked lime. Now let's talk about the effects of temporary hardness. Fouring of kettles and boilers. Since the application of heat to temporary hard water, which contains calcium hydrogen triiosocarbonate 4, makes it to break down into calcium carbonate, which is insoluble. Now this insoluble calcium carbonate can form a coating around the walls of the kettle or the boiler used to heat the water. So you can know that was a temporary hard water, just like it displayed in this picture. Now we also have formation of stalagmites and stalactites in rocks. So when temporary hard water flows into caves, now due to the heat inside the cave, the calcium hydrogen trioxide carbonate 4 now decomposes to form calcium carbonate, which is insoluble, and then they drip down from the top and also from the bottom. So the one from the top is called stalactites and the one from the bottom is called stalagmites. Now let's talk about permanent hardness. Permanent hardness is caused by the presence of calcium or magnesium tetraoxosulfate 6 or calcium or magnesium chlorides. So these compounds here are compounds that can be responsible for permanent hardness of a water. So permanent hardness cannot be removed by mere boiling or by addition of chemicals. So removal of permanent hardness. Number one, we have distillation. Now in distillation, the entire water is evaporated, leaving behind these dissolved salts that are responsible for the hardness. Now the evaporated water is captured and cooled back to give us clean water. Now we also have addition of washing soda, which is sodium carbonate, and it reacts with the calcium tetraoxosulfate 6, which was soluble inside the water, and then produces calcium carbonate, which is insoluble and can be filtered out. Now, a similar reaction can occur if it was magnesium tetraoxosulfate 6. Now we also have addition of caustic soda, which is sodium hydroxide, which converts the soluble calcium tetraoxosulfate 6 into insoluble calcium hydroxide. Let's talk about permutate method. This is the use of an ion exchange resin containing permutate, also known as sodium zeolite, which is hydrated sodium aluminium trioxosilicate 4 and is written as N2P. So the reaction that occurs here is that the calcium tetraoxosulfate 6 reacts with the sodium zeolite to produce calcium zeolite and sodium tetraoxosulfate 6. When the permutate is exhausted, you can reactivate it by pouring in concentrated solution of common salt, which is sodium chloride. The sodium chloride plus the calcium zeolite will now restore back our sodium zeolite again and giving out calcium chloride. Let's talk about treatment of water. Here are the following steps in treatment of town water. So number one is aeration. The water is stirred or allowed to fall from steps to steps to make it mix with oxygen, and this removes iron 3 ions, hydrogen sulfides, and carbon dioxide and volatile gases. It generally removes the odor from the water. So second is coagulation. The water is passed into settling tanks in which sodium alum, this is the formula, or sodium aluminate is applied to help molecules of death accumulate, and since they accumulate, they acquire weight and drop to the bottom, and the water can now be filtered out. Okay, so the third step is filter beds. Now this water that has been removed now is passed to filter beds to remove even finer particles of dirt. Now the fourth step is addition of chemicals. Chlorine is added to kill germs in the water, while iodine is added as a food supplement to prevent goiter, and fluorine is added to prevent tooth decay. Now the fifth step is finally the clean water is stored and is transported for distribution.